So hello everyone, welcome to recitation 13. We are in week 14, I believe. Yes. And in today's recitation, we are going to cover the new topic called databases in this class. And uh, like to be specific, we are going to learn about structured query language SQL, right? So if I just open up this our web page, and if you just go to the schedules over here, so you'll get to know that currently like what in which week we are. And I think from since past 2 weeks we covered up two lectures to just understand about spreadsheets, right? About Excel and different kind of functions and features which comes along with Excel. So over here, of course, we are in our week 14 of course. This schedule doesn't include the Thanksgiving week, but yeah, technically we are currently over here and we are going to learn about databases. And in that, we are going to start off with with SQL, right? And I believe like this is just the second last lecture recitation. After that, the week starting from 12th November, 11th December. That's gonna be the last week. After that, you have your finals approaching soon. If you just wanna quickly see the date of your final exams, it's right here on your home page. It's on December 18th till December 19th, right? So all of the details you'll get to know soon whenever you guys will be approaching for your final exams. And without wasting time, let's get started with today's recitation. So okay, so just a quick introduction. A database. So what is a database? It's just an organized collection of structured information or data typically stored electronically in a computer system. So this is just a standard definition which can be found on internet, right? So, but in simple layman terms, if I just ask you guys that, what do you mean by a database? So we can simply say that it's just a repository or directory or a space wherein we can just dump all our data, right? Now, data can be of different types. Data can be structured data or unstructured data, right? For example, you have your data in the form of images. It can be in the form of videos. It can be in the form of text messages, right? So like there are different kinds of data available out there in the market, but all of the dumping and the storing of the data, wherever we just put it, there's a database for it, right? And a database usually contains different kind of tables in it, right? We are going to look up what are tables, what are relational database, right? And stuff like that in a while. So here also there's a definition of structured query language. Now, again, SQL is a programming language used to communicate with the database and perform various operations on the data. So just as how we studied JavaScript, right, in this class, in this course. So just like that, structured query language is also programming language, but of course, the purpose for both of them is very different. SQL is created just for the purpose to interact with the databases, right? Because like once you have your database ready, but how you are supposed to just retrieve the data from the database for that purpose, there should be some kind of a medium, right? So for that purpose, SQL is created as a programming language, which allows you or the users to just interact with the database, right? And perform different kind of operations on the data. So again, there's one more definition which I found, which was like really interesting. It's like, again, SQL is a programming language for storing and processing information in a relational database. Now, what do I mean by the word relational database, right? So consider a relational database something like in which everything is placed or stored in an organized manner, right? So you have your tables, and inside that, everything is structured, particularly in the form of rows and columns, just as how in the previous two recitations, we learned about Excel in the spreadsheet series, right? So over there, everything was stored in rows and column format, right, in your Excel worksheets. Similarly, a relational database would have a similar pattern of rows and columns, and the data would be stored again in that form, right? So again, a relational databases would be having the data stored in the tabular form, right? So we can use the SQL statements or the queries, right? We can call it queries or statements to for the following, like to perform following operations. One, store. Second, update. Third, remove or search. And lastly, to retrieve the information from the database, right? It's the same stuff. Like, I mean, if you wanna perform different kind of operations with respect to your data, which is stored into the database, for that you have SQL, right? So don't worry, this was just a high level simple definition to just give you an overview about what SQL is and what is its purpose, right? So we are gonna have the hands-on application and try to create our own database, perform different kind of operations to just fetch the data from the database and stuff like that in our this recitation, right? So to start with, I want you guys to just go to this link over here, which you guys can see in front of your screen, right? If not here, of course, and with this, if you go to your files in Canvas homepage, like always, just go to the 00_ recitation information folder, and inside that, you would find another folder of my name, and then go to recitation 13, right, which is today's recitation. Download this database.txt file, right? So make sure you have this file downloaded in your system. These are the slides which I'm using currently, so you can refer to this later on. But for now, for this recitation, just download this text file, and you should be good to go. And just click on this site, so it would look something like this. And if you remember, we have used this similar type of online editor or compiler for our JavaScript series also, right? So this is nothing but an online SQL editor. So over here, you can just perform various, you can write your SQL basically, right? And perform different kind of operations. It has built-in tables over here, which you can see on your right-hand side, right? So let's just try to get the look and feel of how or what does a SQL basic code looks like, right? And okay, cool. So over here, what you see is, okay, so first things first, any programming language, of course, has its own way of syntax, right? Some kind of rules and regulations. So remember, in JavaScript, there were different kind of things declaring the variables. It had different kind of keywords associated with the language, right? So similarly, in SQL, if we talk about this language, if you want to put the comments, of course, you are going to use double hyphen like this. And I can write anything over here. Of course, this will not be counted while compiling this particular code, right? Of course, this is simply a comment, which is just used to just give some kind of clarity to the person who is reading the code, right? So this was just about comments. Okay, so let's just quickly try to understand the first line of our SQL code. So on the right-hand side, if you see, there are a couple of tables, right? We have customers table, we have orders table, we have shippings table. So in the customers table, if I ask you guys, how many columns are present in this table? Just pause this video and think of the answer. We have customer ID, we have first name, we have last name, age, and country, right? So these are some of the columns present inside the customers table. If I talk about the orders table, how many columns do I have? We have order ID, item, amount, customer ID, right? Similarly, for shipping table, we have shipping ID, status, and customer. So what if, of course, this consider this thing that we have a database, and inside the database, we have the following tables: customers, orders, shippings, right? So if you want to just get or retrieve the data stored in these tables, right? How you are supposed to get, right? Of course, we know that SQL serves the purpose for this, but how you are going to use the SQL? So this is the very simple chunk of code wherein we are saying that, hey, I want first name and age column from my customers table. That's it. And again, see, SQL is such a type of a programming language wherein the syntax is very easy. Right? It's just raw English statements, right? Everything is like pretty straightforward and meaningful. For example, over here, the thing which you see in the purple color, right? It's just the keyword, right? So select over here is the keyword. I'm saying select first name, comma, age from customers. So this simply means that, hey, just grab me the following columns, which I'm writing after the keyword select. From whatever comes after the keyword from is usually your table name, right? So here our table name is customers. So select first name, comma, age from customers. And now if I just simply run this thing over here, if you click on this blue button, it will execute this query and it will give the following output, right? it's just giving what we are asking it for, like first name and age, that's it. For example, if I also want last name, right? Select first name, comma, last name, comma, age. So it will also give me the last name. So simple, pretty straightforward, right? And again, one more thing on a side note, just remember that the SQL language is not case sensitive. What do I mean by that? So for example, over here, if you see that select keyword is all caps, right? So let's say if I write it like this, of course, still it's highlighting it in the purple color, right? For the word keyword from also, like if I just write it in this format wherein all the letters are lower caps and still I run, we will still get the output, right? And regarding this tiny little semicolon, I would suggest it's always a good practice to put the semicolon, because in SQL, we have, of course, SQL is a programming language, but we can use SQL in, there are like different kind of database management systems. We have MySQL, we have Postgres, and there are like tons of the systems and like management systems out there, right? So each and every system comes with different kind of slight variation in the syntactical format of the SQL language, right? So some are fine or some are not fine with this thing. So it's always a good practice to just put the semicolon at the end of the end line of your query, right? So I think, yeah, that was just the basic example of how a SQL code would look like. And I think you guys have this idea of how powerful SQL is if you want to just play around with your data, right, which is stored into the database. Of course, in this example, we are just retrieving the data, right? But you can legit update the data, right? You can insert the data, you can create your own database. We are going to look at the example of creating our own database. So for that purpose, I want you guys to just go to your downloaded database.txt file, right? And just give me a minute. Awesome. So here's our downloaded database.txt file, right? So just copy this chunk of code and just remove everything from the window of this compiler and just paste it over here. Again, this is the code for the creation of the table called merge customer, right? So let's just try to understand what this code means. Again, keyword is a keyword over here. Create. Table is also a keyword over here. So if you want to create a table, we simply say create table space table name, of course, right? And after that, we open up the parenthesis, and inside the parenthesis, what usually we give is the name of the columns which we want in our tables, right? So we have customer ID, first name, last name, age, and country. Similar to this, the built-in customers table, which is already available over here. So what we are doing over here, we are going to create our own table, and the name is merge customer, right? Customer ID, first name, last name, age, and country. Notice this stuff over here, which you see. Again, if you remember while learning JavaScript or any other programming language, if you are familiar with, so it usually comes along with the data types of that particular language, right? So in SQL also we have different kind of data types that are usually used to serve the purpose of categorizing the values, right? For example, the customer ID that will usually be in the form of integers or numeric values, right? Of course, consider your RUID. I believe it's a 6-digit number, right? So it's never going to contain letters or alphabets, right? So for that purpose, if we already know, or we can just restrict or give some kind of constraints while creating the column names that, hey, for my customer ID column, all my input data is going to be int. So if you enter anything else, let's say someone's name, it's not going to accept it, right? So here, int is basically the data type over here. What is varchar? Varchar is variable character. Over here, in the parentheses, you see that 100 is written over here. So what is 100? It's just the length which we are specifying that, hey, the maximum length of any kind of value which is going to be an input for my first name column should not exceed the like size limit of 100, right? Of course, like in a real world scenario, no one's first name, to be honest, is going to exceed the word count limit of 100, right? So this is just about the data types which we have in SQL. Of course, there are many other data types which you can just take reference from our favorite site, W3 Schools, of course, right? So again, you can take the reference, but use it just as a reference to just enhance or expand your knowledge. You guys should always use what is covered in your recitations and your lectures by your professor, right? And you should know the scope of the class, right? What things are allowed and what things are not allowed, right? So yeah, I think if I just quickly click on this Run SQL button, it will create a new table. You see on the right hand side, it is merge customer, customer ID, first name, last name, age, country. And in the output section, if you see, it's written SQL query successfully executed. However, the result set is empty. Now, like, what is this? In this also, like we see, it says empty. Like, of course, because till here, we have just created the table. We have not inserted any kind of values into our table. So we got to insert some kind of values inside our table, right? Then only we will be able to retrieve or fetch the data, right? So again, just go to your file. And now, if you see this thing, there's a command written, fill merge customer, right? I'm just going to copy this thing. And now, let me just remove this stuff over here. I'm just pasting it here. So this is the syntax or the code, SQL code to insert the values into the merge customer table. Again, this is also very simple and pretty straightforward. If you see this thing again in the purple, this thing over here, these are the keywords. Whenever you want to insert the values into the table, the syntax goes like insert into. Now, after into, here comes your table name, merge customer. We have values which we want to insert, right? Open up the parentheses, and you will write each and every value according to this particular order in which your column names are, right? So we write 8 for customer ID. For first name, we write Forest. For last name, we write Gum. And for age, it's 55. And for country, it's USA. So in this format, you're going to insert the values. Notice that I'm inserting 1, 2, 3, 4, and 5. I'm inserting 5 records or rows for this particular table called merge customer here. Let me just quickly click on Run SQL button over here. So it says SQL query successfully executed. And over in the right side, you see that now our table merge customer have 1, 2, 3, 4, 5 records in it, right? Forest, Mickey, Jelly, Big, Rudolph, right? So all these things are the values which we just inserted over here, right? So I think that's it, how you can create the table, how can you insert the values. Now, let's say if I want to see some of the records, so I can write it as select. Of course, our select keyword. I just want the first name, let's say first name. Let's say after that, I just want the age and the country. And I can write it as from merge customer. Is the spelling correct? Okay. If I run this thing, I'll be getting first name, age, and the country from this particular table, which we just created, right? So that's how you can just simply create your own table, play around with the values, insert the values, and you can, of course, retrieve the data however you like. So for example, if I ask that I want only the data of the customers whose age is less than, let's say, less than 45. Okay, so from merge customer, there's a slight change over here. We have another keyword called where, right? So select first name, age, country from merge customer. Then I say where age, right, is less than 45. That's it. So here I'm just using conditional operator or thing over here, right? This less than sign is the operator over here. And this is, of course, a keyword. For whenever there's some kind of condition, you use the where keyword, right? So where age is less than 45. If I run this, I'll be getting only 2 records over here. We have Mickey, the age is 44, and we have Jelly, and the age is 34, right? Mickey and Jelly. So this is how you can just play around with the conditions, right? Moving ahead, okay, there's this thing called primary key. So what is a primary key? It is a column or columns that contain values that uniquely identify each row in a table. Let me give you an example to just clear the concept of primary key. So consider you have a table, and inside which you have different kind of columns. First column is RUID, second is first name, third is last name, fourth one is, let's say, major, and the fifth one is your year, I mean freshman, sophomores, junior, senior, anything, and last column can be your address for now. So in this table we have a couple of 5 to 6 columns, right? So is there any way we can identify any row uniquely? Like, of course, for example, the RUID column, right? It will have unique values for each and every row. No two person can have the same RUID. That's 6-digit unique number, right? So I can say that RUID is my primary key for this particular table, because if I have the RUID, I can uniquely identify any row for any particular student. I cannot make the first name as the primary key, because first name can of course be the same for two individuals, right? So for this purpose, we require primary keys, right? Now, what is a schema? So over here, there's a definition, like a database schema defines how data is organized within a relational database, right? This is inclusive of logical constraints such as table names, fields, data types, and relationships between these entities. So it's usually like you'll be having in the database, you'll be having different kind of tables, right? And sometimes you would be having different kind of relationships between these tables, right? And for that purpose, there's something called as foreign key, right? Which is like beyond the scope of this lecture, but let me just give you a gist of what is foreign key. So foreign key is used to just provide the referential integrity from one table to another table. So it's like we have a parent table or a child table, right? So the primary key of the child table would act as a foreign key for the parent table, right? So it's just how we connect two tables between some kind of relationship between them, right? Or common table between the two tables, common column between the two tables, right? So, and of course, sometimes we do have some kind of constraints. For example, while inserting the data, you have created your own table and you want to insert the data into the table. And there's a column called, let's say, RUID, right? So you want to put a constraint that the value or the column RUID should not contain any kind of null values, right? So for that purpose, you can provide a constraint saying that, hey, the user or any person who is just inserting the data or have access to insert the data in this particular table should not be allowed to insert null values. It should compulsorily have some kind of value, some kind of int value inside the column RUID, right? So this is about constraints, right? Don't worry about it if you are like finding it difficult to just relate things, but I think this was the overall gist about how about some of the key concepts of what is a primary key, what is a schema, what is a database, or what are tables, right? Moving ahead, let's just try to perform different kinds of queries in SQL and just see the amazing results. It's going to be fun executing the queries. I just suggest everyone to just perform these queries with me simultaneously, and if you guys are stuck anywhere, you'll get to know, and right, like by seeing the results in the output section, right? So first things first, we have this query called select customer ID, first name, last name from customers. Of course, this will simply give me the columns customer ID, first name, last name from our customers table. Let's just try to see some different. This we already done. This thing we already did because it's just checking the condition where age is less than 26, right? What else? Okay. So let's say I have cross join cross product. Each row in first table is paired with all the rows in the second table. So let's just consider our two tables, which are orders and shippings. Okay. I just want to see the data which is present inside my orders table. Select star from orders. Okay. Now you might be wondering that what is this tiny little thing over here? This is asterisk or star symbol, right? So what thing we got in our output section is our whole table, right? With all the rows and all the columns. So whenever you want to fetch all the rows and columns of the table, you use this star symbol. You say simply select star from your table name, because for example, let's if you imagine that this particular table called orders contained, let's say, 1,000 rows, and if there's a requirement that you want to fetch or retrieve all the rows and columns of this particular table, of course it will be manually very difficult to select, let's say, column 1, column 2, column 3, and so on and so forth till, of course, column 1,000, right? Doesn't make sense. For that purpose, the creators of SQL came with this tiny little symbol which simplifies of selecting everything from the particular table, right? So I say select star from orders. Let's say I want to know what data is in my shippings table. So select star from, is it shippings, right? So we have this data in our shippings table, right? So now let's just try to understand what is cross join or cross product. Let me just copy this statement or SQL query. Select star from orders O, shippings S, where O dot item equal to mouse. Now what is this? So there's something called as renaming the columns or alias, right, in SQL. So over here, if I write select star from orders is my table O. Now what is O? So this means that I have renamed this orders table to O. Like, there's another way of renaming a table. Like, you can of course use a keyword called S also, like orders as O, shippings as S, right? And we can also directly write it as orders space O. It usually means the same. So if I write it as orders O, shippings S, where now I want to check a condition. I only want all the records from these two tables for which the item, or which is the column present inside the orders table, for which the value is mouse. That's it. And now, of course, instead, if, like, let's say if you didn't write this O, so while writing the condition, you would require to write it like this, orders dot item, because you got to specify that item value belongs to which table. You cannot simply write item, right? Because let's say what if the item column is also present inside the shippings table? So that would be the condition of ambiguity, right? So it's always a good practice to just use aliases if you want, and you can just simply write it as O dot item equals to mouse. That's it. And now if I click on run SQL, I'll be getting this particular output. Notice that I have written select star. So I'll be getting all the column values from this particular two tables of orders and shippings. In the right side, you have the whole tables, right? So I'll be getting order ID, item, amount, customer ID, and then shipping ID status, customer from my shippings table. So it has just joined or combined this particular two tables and given the output for a specific condition for only the records for which the value of the item is mouse, right? So of course you can just tweak this thing. For example, if I ask you guys that now I want only the records from these two tables for which the item is mouse and for which the status is pending, right? I don't want to see all the records which are all the items which are delivered. How you will do that? Just pause this video and try to think of the solution and or play around with the SQL code which you see in front of you. Just pause this video. Okay, so if you guys have tried, so let me just try to answer that. Like, of course, the condition, or we have another condition, right? That with the records having the item as mouse, I want only the records having the status as pending, right? So I can simply write it as and status belongs to which table? Shippings, right? S dot, because over here I have an alias name for shippings table, so I can write it S dot status equals to pending. Make sense? Let's just see how it looks like. Okay, so here, of course, see, I have only 3 records right now, right? We have only the items for which the value is mouse and for which the status is pending, right? So in this way, of course, if you have multiple tables in your database, and if you want to just combine the tables, have some kind of conditions depending on to the problem statement, you can play around with your SQL query and come up with the exact requirement, right? So this was about cross join, cross product. Let's just try to understand about union. Used to combine the result set of multiple select statements. Okay. Again, it's always a good practice to just make it the query, make the query run, right? So you'll get to understand by looking at the output. Let me just click the output. Awesome. So I say select star from customers. Again, customers is our table name over here. Union, select. Okay, I can put it something in this manner, so it would be easier for you guys to understand. Select star from customers, union select star from merge customers. So what I'm doing over here is I am combining the resultant output or the result set of 2 different select SQL queries. You getting it? How do we do that? We do that with the help of this union keyword. Union usually combines the records of these 2 different outputs of the select statement, right? So from our first select star from customers, we have customer ID, first name, last name, age, and country. Of course, note that these 2 particular tables have same number of columns with same values, right? Customer ID, first name, last name, age, and country. But after that, the first table, which is the customers, only have 5 records till like first name Betty. If you see that after Betty, the further records of our second table called merge customer are appended. After Betty, we have Rudolph, Forrest, Mickey, Jelly. But note that after this 5, we have the ID again starting from 5, right? We have Rudolph over here, right? Rudolph with the customer ID 5. After Rudolph, we have Forrest. So for Forrest, it's 8, 9, 10, 11. It's going in the ascending order for the customer ID. 1, 2, 3, 4, 5, 6, 7, 8. Double 5 is 8, 9, 10, 11. So this is like usually, I mean, for the sake of practicing, it's fine. But in the real life scenario, we want our customer ID values to be unique. No 2 person can have the same value for the customer ID, right? We see that Betty and Rudolph have the same customer ID value of 5 and 5. So can we change the values of the customer ID? Is there any way? For that purpose, let's just try to understand about updating the records of our table, right? So if you just see this query over here, we have over here, let's say, yeah. If I just run this query over here, and let me just merge this stuff over here. Comment, update merge customer, because Rudolph, first name Rudolph, is present inside the merge customers table, right? So I want to update this particular table. So of course, the query or the way of writing is you use the keyword update because you want to simply update the row value, right? Update table name, which is merge customer, and you write the keyword called set, which simply means you want to modify the particular column, right? So after the keyword set, you usually write the column name. So after the update, you write the table name. After the set, you write the column name. So you want to update the merge customer table, and inside the merge customer table, you want to set a particular value of a column called customer ID to 6, because initially it was 5, right? You want to set it to 6, where customer ID equal to 5. So over here, if you see the merge customer table into the right hand side over here, you want to set the customer ID value to 6 wherever the value of the customer ID is 5. So it is only at one place over here, right? So this is the condition where customer ID equal to 5. You are setting it only wherever you find the value 5 for customer ID to 6. Now, if I simply run this query, run. Okay, so it says it is run, right? Now, if I just again print our union output over here, right? we shall be getting different kind of output for all the customer ID. Notice that now we don't have the duplication of IDs. We have 1, 2, 3, 4, 5, and then we have 6 for Rudolph. The value is updated because of this particular SQL query, right? After that, we have 8, 9, 10, 11. That's fine. Unless and until we don't have any kind of duplicate values, that's fine. All the customer ID values are unique. So it's so much fun and exciting to just do or perform various kind of operations with our data, which is present inside the tables, right? We updated the data, right? So that's how, like, let's see what do we have. We have join, right? So a join clause is used to combine rows from 2 or more tables based on a related column between them. So this is also very much like important. You'll get to see the power of using a join clause. So let's say I remove everything and I write this SQL statement. Select star from customers cust. Now you know that what is cust over here, right? It's just simply an alias or temporary name for this particular table, right? Country C. I can of course write it as C over here, but of course it will be the case of ambiguity, because for country also you want to rename it to C. For customers also you want to rename it to C. Of course, the compiler will get confused that whom you actually want to access, right? So for that purpose, I can write it as cust, right, for customers, and for country I'm writing it as C. So where cust.country, now this particular country column is present inside the customers table, right? So for that purpose, I'm using this alias name cust.country. Country CD. Now what is country CD? If you see the country table over here, oh, for that purpose we don't have a country table. So let's just try to create one more table called country. Let me just comment this for a while. Awesome. Again, if you remember, you have this particular file, database.txt. If you just select this particular piece of code, this is the syntax or code to create a table called country. Create table, table name, and inside that table, we only have 2 columns, country code, which is country CD, and country name. That's it. Let me just run this thing. And here over here, if you see, we have our country table. It should be right here, right? It's empty. We got to insert the data into our country table. Let me just remove this thing. Again, we have one more piece of code which says fill country, right? So copy this, paste it over here. It will just simply insert the values inside our country table, right? I'll just run this code. It says query successfully executed. We have our data, which you guys can see on the right hand side of this online SQL editor, right? We have USA, UK, UAE, and CAN as the country code for the countries United States, United Kingdom, United Arab Emirates, and Canada, right? Because this were the only data which we inserted: 1, 2, 3, 4, 1, 2, and 3 and 4 records, right? So we are done inserting. We're done with the table creation of our table country. We are done with the insertion of the records into our table, right? Now let's just try to understand the power of join. So what I'm trying to say over here is, of course, the country column is present inside the customers table, okay? And the country code is present inside the country table. So notice that over here, of course, can I say that the values, specifically the values present inside the country table of the customers, again, I repeat. So can I say that the values present inside the country column of the customers table are similar to the values present inside the country code column of the country table? Make sense? Right. Because over here, if you see, country column has the values in the form of USA, UK. Basically, it's just the country code. And over here, it's just that the names of the columns in this 2 tables of country and customers is different, but the values are actually similar, right? In the similar format. So we can use a join, which will be applied between these 2 tables, which will just simply join these 2 tables based on a common column. Now you'll say that what is a common column? The column common over here, the common column over here is country code and country, right? No, like, doesn't matter if their names are not similar. We are using that with the help of this syntax, cust.country equal to c.country code, right? You'll see like once I'll get the output over here, I'm executing the query. So see that we got the records, 5 records for combining the columns of these 2 tables of country and customers, customer ID, first name, last name, age, country, country code, and country name, right? But only for the records for which cust.country is equal to c.country ID. So see that over here, USA, 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 right? UK, UK, the values are matching, and we only fetch those records for which these 2 values are matching, right? So, I mean, this is just about the SQL join clause, right? What do we have it? Of course, we have something called as a nested query in SQL. Now, what is a nested query? Again, let's just try to understand with the help of running this query, right? So select star from merge customer where I'm selecting everything present inside my table called merge customer, and there's a condition where age is equal to. So I want only the records for which the age is equal to. I'm not saying that for where age is equal to 25 or let's say 36, but rather I'm saying that equal to, and in that I'm writing another select query, right? We can do that. Yes, this is possible. And this is nothing but called as a nested SQL query, because after this equal to, I'm writing another SQL query. So what do you mean by the word nested? It simply means that you have one SQL query written inside another SQL query, right? So I say equal to select max of age from merge customer. Now, just for a while, ignore this keyword called max. Just ignore it. Select max of age from merge customer. Okay, run. I'm getting some kind of output, right? I'm getting the customer ID for which the value is 8, first name Forrest Gump 55 USA. So it's just displaying or showing me the output for which the age value, max value of the age from merged customer. If you see this table, what is the max value of the age? It's 55 over here, right? So it's giving me that value for which the age value is that. That's it. That's it. This is something about the nested query. Now coming to the word max, right? So in SQL, we usually have something called as aggregate functions. So if you see over here, aggregate functions, they just written a single value calculated from the values in the column. So in the aggregated functions, we have something called as average. Of course, that will return the average value of all the total values present inside the column. We have something called as sum. We have something called as count. It will just simply return the number of rows. First, last, return first and last values respectively, and max and min, of course. So let's say, of course, this is again pretty straightforward. Let's just try to understand with this simple SQL query, which will return the average of the amount column present inside the orders table. So I write it as select. Average is again a keyword, or of course it's just an aggregate function, so you will not be seeing into the purple highlight color, but of course you can write it in lower caps or all upper caps, that's fine. Average of amount in the parentheses, again, don't forget the syntax of your writing, as average, right? This is just but the alias name for the column which it will show you in the output from orders. Let's just run this query. 2670. You got that right? So this is just showing you the average value for all the values present inside the amount column in your orders table over here. So let's say if I want to know the max value, you know it over here, right? It's 12,000, right? So it should give you the output as 12,000. So you see that? It's working correctly, right? So you have aggregate functions to perform the aggregate function operations, right? You can write it as count, right? You'll be getting as 5 because 1, 2, 3, 4, 5. You have 5 values into the amount column. It will just count will simply just return the number of rows present inside that particular column, right? So I can try out different kind of aggregate functions on different kind of tables and examples and just play around. It's just fun and you'll enjoy it, right? What else? Yeah. One more thing which I want to cover is grouping or group by. Yes, this is something very important, right? So let's say I'm selecting this query. Let me write it in this way. Select customer ID, sum of amount from orders group by customer ID. Now you are in that stage wherein you will be able to understand the SQL query, right? Selecting the columns called customer ID and the summation of the amount. Sum is the aggregate function which we have used for the amount column from the orders. Orders is the table name, right? And now this is something new, group by customer ID. Now, what do you mean by group by? For that purpose, let's just quickly see the output. So it's like 1, 2, 3, 4, and the summation of the amount, right? So if you see the orders table over here, we have our records in 1, 2, 3, 4, 5, and different kind of amount values, right? So group by is usually done to just, as the name suggests, it just groups by the value for or by a particular column. So here our column which we have written is customer ID. So it's just grouping the values. For example, over here, if you carefully see our orders table, note that over here in my group by clause, I have passed the column customer ID, right? And in the orders table, you have customer ID table, right? We have values 4, 4, 3, 1, 2. We have order ID 1, 2, 3, 4, 5. So again, let me just try to give you a very beautiful example so you'll be able to relate it. Let's say, of course, I'm sure you guys might have used Amazon, right, to order any kind of stuff online. So let's say this is your small, tiny table of the transactions taken on a particular day. We have order ID 1, 2, 3, 4, 5. There were 5 orders placed today, and then these are the items which were ordered, right? Keyboard, mouse, monitor, keyboard, mousepad. This is the amount which is spent by the customer, and this is the customer ID. Notice that, of course, customer ID can be can repeat, right? Because one customer can order many items, but of course, the order ID of those items will be different, right? So over here, if you see customer with or so the customer with the customer ID 4 has ordered 2 items called keyboard and mouse, for which the amount is 400 and 300, and still it has, of course, 2 different order ID, right? So there's a requirement where you want to see the summation of the total amount spent by each and every customer on this particular day. So you say that, okay, I can simply do that by using a group by clause. I'll just write it as group by customer ID. So if you see that 1, 2, 3, 4, of course, so for 4, so summation is 700. How come? So you see this 400 plus 300. These are only 2 values available for customer ID equal to 4, for which the summation is 400 plus 300, and that's how we got 700 over here, right? So for customer ID equal to 3, of course, there's just one row or transaction or the order made by this particular customer. So it's 12,000, right? Similarly for customer ID equals to 2. So this is how you can just get the records in the form of grouping. This is called grouping mechanism, right? By using this group by clause. And it's very powerful, and it has various use cases in real world scenarios, right? So this is something very important in the world of SQL. And what else do we have? We have covered joins, grouping. I think nested query, yeah. So I think pretty much everything is covered. I want you guys to practice on your own about by creating your own tables. Let's say you can come up with your own table, right? You can have you can create a table. For example, if I was supposed to give you a practice problem, just you can create a table of the example which I mentioned earlier, which will have some kind of columns. That's RUID, first name, last name, your major, your address, or your year, right? And just try to insert some of the records of you and your friends, right? You can insert 5 to 6 records and just try to play around that. You want to you can also have a column called grade, and you want to print or output only the records for which the major is so and so, the year is so and so, and the grade is so and so, right? So it's really exciting. I genuinely love playing around with different kind of data operations in SQL, right? So I think pretty much everything is covered for this particular recitation. We are gonna see that what we have for our next upcoming recitation number 14, and I believe that would be the last recitation for this wonderful CS170 course series, right? So stay tuned, stay connected. I'll let you know what we have, and I'll keep you guys posted via our Canvas announcements, right? Make sure you mark your attendance, and with that, let me just give you the secret code for this particular recitation. The secret code is 931. I repeat, let me just write it somewhere right here. It's 931. I hope this is visible, right? The secret code, this is for recitation 13, today's recitation, right? So make sure you mark your attendance. This should be live by December 6th night, right? So I think, yeah, we are done with our recitation timings. And do let me know if you guys have any questions or concerns or queries regarding anything, or your assignments, your grades. We have our office hours tomorrow on Thursdays from 2 to 3, which are virtual, right? So make sure you connect with me if you have anything else. Until then, see you guys next week. Thank you.